Hi everyone! Today we're going to talk about how to find the equation of a line in point-slope form, given various pieces of information about the line. To complete this problem, we'll identify the components we've been given, plug them into the point-slope formula, and then simplify the equation. Let's take a look. With this particular problem, I want to demonstrate how you can find the equation of the line in point-slope form, given various pieces of information about the line. So what I've done here is classify into three separate groups pieces of information that you could be given about a line, and then we'll look at each group to figure out how you would find the equation of the line in point-slope form. So group number one, if you're given the slope and the y-intercept, or the slope and a point, or a horizontal line, or you're told that the line is the horizontal line through a point, or the horizontal line through a y-intercept, all of those are similar in the sense that essentially, you're being given a slope and a point no matter which of these you're given. Obviously, the slope and y-intercept, if it's the y-intercept, then it's the point. In this case, we've been told that the y-intercept is 3. It's the point 0, 3, right? Because x is equal to 0 when the graph intersects the y-axis. So if you're given a slope and a y-intercept, and the y-intercept is 3, then the point really is just 0, 3. Obviously, that's the same as the slope and a point. So if you're given a slope and a point, it's really the same thing as being told the slope and the y-intercept. In either case, you're still given a slope and a point. And the same thing goes for these two sets of information, horizontal line through a point or the y-intercept. The slope of any horizontal line is just 0. So essentially, you're being told that the slope is 0 and given a point, or that the slope is 0 and given the y-intercept, which is also just a point. So regardless of which of these pieces of information you're given, you're going to go about finding the equation of the line in the same way. That'll be slightly different than if you're given 2 points on the line, which is its own category, and that'll be slightly different than being given a point on the line and being told that the line is parallel to another line. So we'll talk about each of those. Before we do, let's recall that the equation of the line in point-slope form is the equation I've written in blue here, which is y minus y sub 1 is equal to m times x minus x sub 1. So basically what you have to think about with this formula is that m is the slope of the line, that xy will remain in your function, and that x sub 1 and y sub 1 represent a point on the line. And so when you have a point, you plug it in for x sub 1 and y sub 1. That's why it's called the point-slope form, because you're plugging in for the point, x sub 1 and y sub 1, and the slope, m. So let's go ahead and look at how we could be given these different pieces of information and still get to the equation of the line in the same way. So if we're given, for example, the fact that if we're given the pieces of information that the slope is -2 and the y-intercept is 3, we need to realize that the y-intercept being 3 means that we have the point 0, 3. So what we'll do is we'll say y minus, and then the y-coordinate of the point 0, 3, which of course is 3, is equal to m, the slope, which we know to be -2, times x minus the x-coordinate of the point that we're given. Remember that we're given the point 0, 3 because this is the y-intercept. So 0 is our x-coordinate there. So notice how we plugged in the slope and the point 0, 3. This has been plugged into the point-slope form, and we could leave it like this except that we have this 0 here. So we could simplify to say y minus 3 is equal to -2x, and we could even change this into y equals -2x plus 3, which is now slope-intercept form. Either way. Obviously, we can do the same thing if we're told that we have a slope and a point, -2 and 0, 3, or even if we were given the point here, 1, 1, right, which is also on the line. We could say, let's pretend we're given the point 1, 1 instead. We could say y minus 1 is equal to -2 times x minus 1. So we plugged in our x-coordinate 1 here, our y-coordinate also 1 here, and our slope -2. When we do that, we can leave it in this form, or we can choose to simplify and get -2x plus 2. If we add 1 to both sides, we'll get y equals -2x plus 3, and notice we're back at the same place that we ended up with when we got the other set of information. So that's how you deal with it if you have a slope and a y-intercept or a slope and a point. Again, if you're told this line that we're dealing with here isn't a horizontal line, but if you were told it was a horizontal line, you would know that the slope is 0, and you'd plug in 0 for m, and then you'd plug in whatever point you have for x sub 1, y sub 1. If you're given 2 points, as we are here, the points 0, 3, and 1, 1, you'll need to use them first to find m. So the way that we're going to do that, the equation for m is actually y sub 2 minus y sub 1 divided by x sub 2 minus x sub 1. And what you want to do is you want to take 1 point. It doesn't matter which point you call x sub 1, y sub 1, and which one you call x sub 2, y sub 2. But let's say that 1, 1 here is x sub 1, comma, y sub 1, and that 0, 3 here is x sub 2, comma, y sub 2. So if we just plug those values in, y sub 2 is 3, y sub 1 here is 1, x sub 2 we know to be 0, and x sub 1 we know to be 1. So we'll get 2 divided by negative 1, which is a negative 2. That's how we find the slope m. So now we'll take the slope m and either one of these points, it doesn't matter which one, and we'll plug them into our point slope formula. So we'll get y minus, let's go ahead and plug in 1 and 1 again, 1, 1, doesn't matter again, but y minus 1 equals our slope that we found, negative 2, times x minus 1, and again, it's the same thing we ended up with here. So we can just simplify to negative 2x plus 2 if we want to, and if we want to, we can add 1 to both sides and transform it immediately into slope-intercept form if we want to. This top line here represents point-slope form. The bottom line represents slope-intercept form. And lastly, if you're given a point and the fact that the line is parallel to another line, essentially you're being given the point here and again a slope, which you can see here. So this equation, y equals negative 2x minus 6, is in the slope-intercept form, which is y equals mx plus b, m being the slope. So negative 2 is the slope of this other line. Remember that lines that are parallel have the same slope. So essentially we're being given a point and a slope, and we're right back here into group 1. So you just have to pick the slope out of this equation and then say y minus our y coordinate here, 3, is equal to the slope here, negative 2, times x minus our x coordinate here, 0. And then again, you can leave it like this, or you can simplify negative 2x, and then if you want to, y equals negative 2x plus 3. But notice how no matter what piece of information we're given, we can quite easily get the point-slope form of the line, and we can quite easily transform any of those into the slope-intercept form of the line. And no matter which method we use or what information we're given, we always end up with the same result.
So I hope you found that video helpful. If you did, like this video down below and subscribe to be notified of future videos.